So the first one I'm going to import is pandas. So I'm just going to write import pandas as PD. So PD is just
the short form.
Yeah, the short form, and it's convention to import pandas as PD. And for now, I think I'll also import the matplotlib. So this is a plotting library, which we will be using to some extent. So matplotlib.pyplot, and we're going to import that as plot, plt. Okay, and we're also going to import Seaborn. Seaborn is a library built on top of matplotlib, and it allows for nicer visualizations. Yeah,
makes things look pretty.
Yeah, and we want to make some things here look pretty, and you'll be seeing how we do that in just a bit.
Seaborn is one word.
Yeah, Seaborn is one word. Okay, Seaborn. There we are. Okay, so now we have a library, so I'm just going to run that using Shift-Enter. Okay, so now the first thing we want to do is we'll make a data frame. So I'm going to call our data frame dataset. And I'm going to use the Panda library. So we're going to use pd.read underscore CSV. Yeah. Okay, and then let's see. So we give the name of the file, which is autompg.data. And then because it's not exactly a CSV file, we have to actually specify that's delimited using white space characters. White space. And we'll say true to that. Because CSV files are usually delimited using commas. So in this case, we have to specify that it's delimited using white space. And another thing that we'll do, I'll show you why. I'll show you why we're about to do what we're about to do. So I'm just going to show you what the actual file looks like, so you can kind of have an idea for why we're doing what we do. So .data. So I'm just going to have a look at the file here. Okay, so we can see the file here, and you can see that we have the columns, but we don't have a title. Okay, which is why I need to specify that the names of the columns. So the first one is MPG. The second one, what is it? Cylinders?
Cylinders.
Yeah. Cylinders. Yeah.
Displacement.
Displacement. That's a string. Displacement. Yeah.
And then horsepower.
Horsepower.
Weight.
Acceleration.
Model year. I would have an underscore just to.
Oh yes, yeah.
Oh, maybe not. Doesn't matter. Origin is where the car was made. And then car name is a string.
And we'll do underscore as well, just to keep consistent. Okay, great. So what this will do is give me all the column names in my data frame.
Yeah. So if you see the description, you can actually see what the columns are.
Yeah. So essentially, if you wanted to know what the columns are, these essentially match up to these columns here. So it's MPG, that's cylinders, displacement. And I think you get the idea. So we're going to run that now. I'm just going to run that. It's going to make our data frame, and I'm just going to get rid of this.
Just we can override it.
Yeah, okay, we'll just do that. Okay, so now we have our data set, and the first thing we want to do once you have a data set is just have a look at it. So I'm just going to do dataset.head, and what that will do is it'll show me the top 6 rows of the data set. 5 rows of the data set. Okay, so it looks all right to me. We have the correct the names of our columns. We have all the data. It looks okay to me. So from now, we're going to continue. From this point, we're going to continue on, and we're going to have a look at the shape of the data set. So I'm interested in how many rows are there? How many columns are there? We can see how many columns, but how many rows is something that really seen. And we're going to run that. So we can see that we have 398 rows in our data set and 9 columns. Okay. So then we're going to have a look. So one of the things that's really important in data science is cleaning, and now we're moving into that cleaning step. But first we have to identify whether or not there's anything that we need to clean. So in this, I want to check, are there any null values in my data set? So this happens if data maybe wasn't recorded, and then they've used nulls to denote that the data wasn't there. But we want to get rid of those. So I've checked now whether or not there are nulls. There are no nulls, and I can continue on from here. Okay, so should we look at the description for the data set? Yes, I think that's probably a good idea. Describe.
Yeah, just to get an idea of what the summary is for the data set.
Yeah, so this is a little bit hard to understand. We'll be graphing some of this in a bit, but you can see just off the bat the count we saw before, 398 rows. We can see the mean for miles per gallon. So the average car has a miles per gallon of 23 miles per gallon. We can also see the minimum. So these are the worst, gas guzzling cars, and these are the best, the max. And we can also see the quartile, interquartile range as well, and the upper and lower quartile.
Yeah. And the 50th one is basically the median.
Yeah, so the median, and this is the lower quartile and the upper quartile.
Something you can sort of see is like if the max is really, really big, you can see if there are any like obvious outliers, but we'll probably graphing is probably a better way to see it.
Yeah.
Just to get an idea.
Yeah. Okay, great. So the next thing we're going to do is we're going to actually have a look at the types in our data set. So we're going to do types. Okay, and what this allows us to do is just to make sure that everything is as we expect it to be. So if we just quickly scroll up, we see that here we expect the miles per gallon to be continuous, discrete, and so on, and then the car name to be a string. And we would expect our data to look like that. I'm going to scroll back down here, and we can see that most of these are fine. Floats, integers, all of that looks okay. And the only problem is horsepower. Object here in pandas usually denotes a string, or strings are denoted as objects in pandas. And we see that horsepower is likely a string. So we'll have to figure out
some sort. Yeah.
Yeah. So
and if you look carefully at the describe thing, there are you can see 7 columns, and in the describe stage, pandas only describes the numeric columns.
Yeah.
So if you see there's 7, but there's supposed to be, if you look at the columns, there are supposed to be 8.
Almost. Yes. Yeah. Exactly 8, because we have 8 that's supposed to be numerical, and 1 that's a string, which is a car name. So that could have also given you an indication, but this is one way to check. So from there, we will actually move on to. So actually, first,
if you want to it is essentially, because if you go up here, it says missing attributes values. Horsepower has 6 missing values.
Ah, yes, okay.
And if you actually have a look at the data, do you want to have a look at the data just to see how those?
Yeah, so I think we should probably do that next. So this is
they're essentially denoted as question marks.
Yeah, so we'll move on to the cleaning step here, because we'll have to remove some of the things that aren't correct in this. So what I'm going to do is I'm going to look at all the unique values in the data set for the horse column, and what that will allow me to do is identify anything that isn't. Because as we saw, there is something that's not correct there. So I'm going to horsepower. Okay, and then, so what this is doing at the moment is I'm referencing the data frame, and this is allowing me to look at one particular column, and now I'm looking for all the unique values in that column.
That's the method. So
okay, so actually, let me just okay, great. Okay, so as we can see, all of this looks quite what you'd expect. The only thing that looks out of place here is the question mark. This is not a number, and which is why pandas decided to assign this whole column as a type string. So we're going to have to get rid of that. So to get rid of that, we're essentially just going to find it and clear it out. So all the places that happens, we move. We can't replace it because we don't know what the original horsepower was. So where we have these missing values, we're just going to remove the row. And there's only 6 occurrences, as we saw in the description of the data as well. So it won't be removing too much of our data set. So dataset locate. I'm going to locate. I'm going to locate all the places in the horsepower column where the value is equal to the question mark.
Oh, not equal to. Oh yeah. Yeah.
Oh, yeah,
so we want to keep the ones that.
Yeah. Okay. So So not equal, exactly. So what this will say is, okay, if it's not equal to the question mark, keep it. If not, throw it out. So we'll run that. We run it. Now we have our new data set. Okay. So now we'll move on from there.
It's still a string.
Yeah.
So we should convert all the strings to a number.
Okay. Yeah. So what we'll do then is we'll say dataset is equal to yeah, so I think I'll be able to. So we're going to assign something new to this column here. So we're going to say dataset, and then horsepower. Then we're going to do as type here, and we're going to declare the type as a float. Yeah. Okay. Great. Okay, so now we should be good. Just to check, I'm going to quickly run the same command that we ran before. So I'm going to go dataset.dtypes.
Yeah, you can also do describe.
Oh, not callable. So there we are. Okay, so let's have a look. Okay, that's a float. Okay, and we're good to go now. So everything is now as we expected it. And now we can move on and look at the distributions of these variables in the data set. And so to look at the distributions, we're just going to use the inbuilt histogram function in pandas.
Yeah, that actually comes from matplotlib, but they're all sort of connected.
Yeah, so matplotlib, a lot of libraries, a lot of graphing libraries are built on top of matplotlib. So Seaborn is also built on top of that, as I mentioned. Okay, and we'll do a 10 by 10 grid. Yeah, so what that allows us to do is we're essentially going to map out all the...
Basically create histograms.
Yeah, basically create histograms. You'll see what we... Okay, great. So, okay. So we can see here that acceleration looks to be a normal distribution. It's continuous. Cylinders is discrete, as was mentioned.
Yeah, it can be 1. Is that 2, 4, 6, 8?
Yes. Yeah. And
so, you can see they're relatively they look fine.
Yeah. So essentially, what we're looking for is just to understand the data here. Maybe this will inform some decisions we make later on, but for now, everything looks as it should. We can also see that miles per gallon is seems to be skewed to the left here. So the majority of your cars will have poor miles per gallon, so poor fuel economy, which is an interesting thing to note. So I think we'll move on once we've seen that. Now we want to know what the relationship is between the variables. So, for example, if we take weight, what can that inform? Can that give us any information or tell us anything about, say, miles per gallon? Is there any sort of relationship there? So we're going to use Seaborn now, and we're going to use a pair plot. And we're going to call that on the data set. Okay.
It's big.
Yeah, so make sure it's nice and large. The size parameter has been renamed to...
Yep, you can change that, but right now it should be working. It's just a warning.
Okay. So yeah, so we probably should actually ignore warnings, but for now it should be fine. Okay, so it's quite large. It's a little bit difficult to see, but so you can see on the x-axis or along the
y-axis.
Along the y-axis, you've got the names of variables, and along the x-axis you also have names of variables. So we can see that there are relationships between them. So let's say weight. And displacement. So here there seems to be a positive relationship, and they seem to be somewhat correlated. But we're more interested in miles per gallon, so let's have a look at that. So we'll look at this down here. So of course that's correlated with itself. So an interesting one might be here, horsepower, displacement, and weight. So if we scroll up these three columns here, so you see there's a negative relationship between miles per gallon, horsepower, weight, and also displacement.
Yeah. So as the weight increases, the fuel efficiency, the miles per gallon increases, which means it's less fuel efficient.
Oh, miles per gallon decreases, right?
Yes.
Yes. Yeah. Because
So
the lower the miles per gallon, the less fuel efficient the car.
Yeah.
And as we can see, that is the case. So the greater the weight, the lower the miles per gallon. Okay, great. So I think we've understood that enough. I think we'll drop another little plot to make it more clear. Maybe this isn't as easy to see, but this makes it easier to explain correlations. But now we're going to create a little bit of a matrix here, using another one of Seaborn's functions. So I'm going to plot these subplots. And we're going to use the same, actually we're going to use 16 by 10, so fig size. Do 16 by 10. Okay, and we'll get the correlation matrix. Matrix, okay. And we'll be able to use a function built into pandas to essentially give us the information. It will generate a matrix for us.
No, we need the heat map. We need
yes. So Seaborn has a heat map that is quite useful in this case. So we can use the correlation matrix again. Copy it over. And we want to annotate it, so that will give us the correlation. Annotate. Correct. Annotate is equal to true, and then we're going to use
color map.
Yeah, so I quite like. Let's do orange and red. I quite like that. Orange and red, and then of course we have to show the plot. Okay, let's have a look at that. Okay, so it looks like, so this is essentially the same information we saw above, just in a different format. And we can see that the color scheme here, so as you know, correlation ranges between -1 and 1, where 1 is positively correlated, so exactly positively correlated. So if you have, say, for example, let's see. So of course, every variable is positively correlated with itself, with a value of 1. So that's essentially just saying
Perfect correlation.
Perfect correlation, right? Exactly. And then, of course, you have the inverse of that, which is negative correlation. So if one goes up, one goes down. And that's true for the correlation between cylinder number, miles per gallon, displacement, miles per gallon, also weight and horsepower. So you'll see that as weight goes up, you expect miles per gallon to go down. And that's quite a strong relationship, as we saw above as well. Okay. Is there anything else we can say about data based on that?
I mean, you can. This is usually a good way to remove the ones that are obviously not related.
Yeah.
So in the car case, if we had a variable called color here, that you don't expect to be related to the miles per gallon.
Yeah.
So you would probably see a correlation of 0, close to 0.
Yeah.
And so we can use a plot like this to basically remove the ones that are not relevant at all.
Yeah. Okay. So a correlation of 0 just says, this variable doesn't give us any sort of information about another. So knowing the value of one doesn't really help you figure out the value of another. Okay. So the next thing I think we'll do is should we plot the miles per gallon?
Yeah, we can do that.
Yeah. Okay. So I think we'll just have a quick look at the distribution of the miles per gallon. We've already had a look above, but this is just another way of doing that. So if you choose to, you can use this method as well. So this is another Seaborn it's another Seaborn function that we're using here. I'm going to plot the miles per gallon and just have a look at that. So yeah, as we can see, it seems to be skewed, and of course, there seems to be less fuel efficient cars than there are unfuel efficient cars. Okay, great.
So yeah, I think we can build a machine learning model now.
Yeah. Do you want to jump in on the spot?
Yeah, sure. So for our machine learning library, to create a machine learning library, to create a machine learning model, we're going to use the library called scikit-learn. So we sort of need to import that library. So we'll go import sklearn. So there's a few things that we need to do before we play with our model. So we'll import a couple of things, and I'll explain to you what they mean. So model selection, import train test split. So we need to divide the data set into a training set and a testing set. So that basically, the best way to think about that is the training set is basically think of it like a college, university exam. And the training set is basically what the model trains on. And the test set, you can think of it like the exam, that we don't show the model while it's training, while it's learning. We let the model train on the training set. So learn on the training set, and then evaluate how well it does on the test set.
Yeah, I think that's a pretty good analogy, because your professor wouldn't give you the test they'll be sitting at the end of the year during the semester to practice on, because otherwise everyone will ace the test, of course, right?
Yeah. So you can basically, if you don't do that, you can basically memorize the final exam.
Yeah, and we don't want our model to memorize the final exam, because that wouldn't give us a very accurate sort of view of how good the model actually is.
So we'll use that to basically split our data set into.
Something happened there.
Oops, what happened? So I guess the first thing we sort of need to do as well is our data set. We need to convert it to the X and the Y. So the input and the output. So right now our data set contains both the miles per gallon, which is the answer to our question, and also the things we learn from, like the weight. So the first thing we'll do is we'll get data set dot. We'll drop the empty miles per gallon column, so that the data set does not have the X's don't have access to the miles per gallon column. So before we do the train test split, we will do that, and then we'll see the head of that. So you can see, oops, what did I do him from?
Oh, yes, yeah.
So we can see that the miles per gallon is no longer in X, and then we will also Y. Our Y will essentially be the miles per gallon. So dataset MPG, and then we can see the Y dot head. So that's just the first four values of the dataset. And then we will do the train test split. On the x's, you need to give it the y's, and then you need to tell it how much of the data to use as the test. So the test size would, in this case, we'll use 20, maybe 30% of the data as the test set. So that means that 70% of 398 rows will be used as training, and then 30% will be used as the final exam, basically. And then we could, just to make sure that everybody has the same, we can set a random state so that we get the same answer every time. Otherwise, it'll be randomly split in the. It'll shuffle the data set and randomly split it just so that we're consistent. So we're running the linear regression model, so we also need to import that. So we'll import that from the same library. So from sklearn.linear model import linear regression. So so how do we know what sort of thing to import? Maybe it's probably good to go to the scikit-learn documentation.
Yeah, so going to the documentation is a really good way of learning. So if there's something that you want to achieve, or even if you just want to know what's possible, it's really good to just visit documentation.
So you can, so there's the linear regression model, and you can, otherwise you can see what sort of other models are available as well.
Yeah.
So in this case, we're doing regression, which means it's regression because the per gallon number is a continuous number. In the case of like classification is basically like if there are discrete categories like cats and dogs, and regression is basically trying to predict a real number. There are obviously a lot of things here, but
so something you can look at if you're looking to get a little bit creative, and you want to think outside the box a little bit. You don't want to use a linear regression.
Yeah, there's a few examples there about regression, support vector regression, or all the other ones as well. So we'll be using linear regression. So we will import that. And so we first need to create the model, basically. So that'll just be linear regression. And then we need to, after we create this model object, we need to fit it to our data. So we will fit it to the training data, which is the train X. By the way, another cool trick is if you press Shift and Tab, it'll come out of what you actually need to type in. So the first it expects is the X and then the Y. So we'll put the train Y. And then is it expecting anything else? We don't have to worry about the sample weight.
So by default, it's none, which is why, which is denoted in the docs there as well.
What did I do? Could not convert string to. Okay, so so we also have in the X, if you remember, there's the car name. So the machine learning models can only work with numeric data. So we need to drop the car name as well. So that will create just the numeric numbers. And then we need to run the train test split again. And now we should be able to fit it. So model.fit, and then that would have fitted our model. One thing we can do, if you go here to the linear regression, you can see that there's an attribute called coefficients. I think we should be able to see what it did. Model dot. So you can see these are the different weights it applied to each of the inputs. So in this case, the cylinders was weighted by negative 0.35. So these are basically the M's that the model learned from the data. And we can, after we've trained the model, so we've trained the model in this step, we can use that to predict on the test data set. So model dot predict, and then give it the test x's, and predicted would give what the outputs of the model is. We don't have to. Another thing we can do is we can plot the predicted and the test y and the predicted, and then see if we got. Okay, that might not be the best.
Try scatter.
Is it plt.scatter?
Yeah, that's it.
Okay, so we can see that. But if we want some numbers, we do have the model.score.
Yeah, so this lets us quantify how good the model is.
Yeah, so we can have test x and test y. We give it the answers, and then it'll score the model, and then we can see that it got 80% accuracy. You can go here and check what score actually means. The R squared, basically how fit it is. So you can see it's relatively bunched up close together, the predictions and the actual results. So yeah.
Yeah, so that basically tells you how accurately, based on the other variables, the model can predict the miles per gallon. That's saying that sort of 80% of the miles per gallon number is predicted by the variables that we've used.
Yeah. So it is not. So if you want to use a different model, you can just change the actual model type here to use random forest or whatever other model is. And the other things you could see is maybe some of these columns are not very relevant. Maybe you think the origin column is not actually useful. So we can create another model by dropping that column and seeing what happens to the model, if it increases or decreases.
Yeah, but I think we'll leave that for them to try out.
Yeah.
So these are things that you can think about, and also if you want, you can maybe apply other models because, for example, linear regression is quite a simple model, and the random forest maybe would yield better results. But that's something you can play around with. And then if you want to get, if you're looking to get further into this topic, have a look at how you can improve the score and how and those sort of things.